Geometric sequence is a sequence where a fixed number is multiplied to get the next term of the sequence. For example, in here, 2, 8, 32, 128, 512. Each time as I'm going to the next term, I'm multiplying by 4. So each term is being multiplied by 4 to get the next term. That kind of sequence is called a geometric sequence, and the number we use to multiply to get the next term is called the common ratio r. In this case, we were multiplying with 4. We could be multiplying with a positive or a negative number. Is the given sequence geometric? If so, what is r? So to check if the given sequence is geometric or not, we can go ahead and divide so this is a1, a2, a3, a4, and an. We can divide the second term with the first. We can do a2 over ar, a3 over a2, or a4 over a3. All of these ratios have to be equal. So looks like as I'm going, I am multiplying by 2 each time. So it is, yes, a geometric sequence. And what is the common ratio r? To find r, we can divide any two consecutive terms. So r is equal to 2 in this case. The next example looks like we are multiplying. As I'm getting to the next term, we are multiplying with a negative 1/3. So r is negative 1/3, and yes, we are multiplying with negative 1/3 to get the next term. So yes, it's geometric, and r will be negative 1/3 in this case. Another example, the nth term of geometric sequence, the formula for the nth term is an equals a1 r to the power n minus 1. Because to get the second term, we multiply with 1r. To get the third term, we multiply with r squared. To get the fourth term, we multiply with r to the third power. So to get the fourth term, multiply with 1 less than the number of term we have, r raised to that power. So for the third term, we raise r to the second power. Second term, we raise r to the first power. For the 10th term, we will multiply r to the 9th power. So one less number. So the nth term in this case would be r n minus 1. A is the first term, which is a1, r to the power n minus 1. R here can be found by dividing second term with the first term, which is 5. So to find the nth term, we can use this formula, and we can use this formula to find the 100th term of the sequence without writing the 100 terms. So if I wanted to find the 100th term of the sequence, I could just go ahead and plug n as 100, and we can figure out the 100th term would be 15 times 5 to the power 100 minus 1, which can be calculated using the calculator. 15 times 5 raised to the power 99. And that's going to be 2.36 times 10 to the 70 power. So a really, really large number. 2.36 times 10 to the 70th power, written in the scientific notation. Right, write the first 5 terms of the geometric sequence whose first term is a1 equals 3 and the common ratio is r equals 2. To write the first 5 terms, we're going to start with a1. Next term would be a1r, a1r squared, a1r to the third, a1r to the fourth. So a1 is 3. Now multiply by r. Next is 6. Next term would be 12. 24, keep on multiplying with the common ratio r, which is 2. Find the 15th term. We want to find the 15th term of a geometric sequence whose first term is 20 and the common ratio is 1.05. So 15th term, the nth term formula is a1 r to the power n minus 1. So a15 would be a1 r to the power 15 minus 1 is 14. Now all we have to do is to find the 15th term. We're going to plug the a1, the first term, which is 20, and r is 1.05 raised to the 14th power. We can use a calculator to figure this out. It's going to be 39.599, and that's going to be the 15th term of this geometric sequence. Another example, find a formula for the nth term for the following geometric sequence. What is the 9th term of the sequence? So first of all, to find the formula for the nth term, we know an is a1 r to the power n minus 1, And we do need to find the r in this case. The common ratio r can be found by dividing 15 with 5 or 45 with 15. And that's going to be, we're given that this is a geometric sequence, so we don't need to check. So r is equal to 3. So formula for the nth term would be a1, 3 to the power n minus 1. Or we can put parentheses around if we want. 5 times 3 to the power n minus 1. That's a formula for the nth term in this case. Now, if you wanted to find the ninth term, we can just go ahead and plug to this formula can actually be used to find any term of the sequence. A9 would be equal to 5 times 3 to the power 9 minus 1, which is 5 times 3 to the power 8, and that would be 32,805. That's going to be the ninth term of this sequence, and we can find 9,000th term as well, just using the nth term formula. The fourth term is given and the 10th term is given. We want to find the 14th term. Assume that terms of the sequence are positive. Okay, so fourth term, the nth term general formula for the fourth term would be a4 is a1 r to the third power. So if I plug, fourth term is 125, a1 r to the third power. And the 10th term would be a10 equal to a1 r to the ninth power. And we have 10th term as 125 over 64, which is a1 r to the ninth power. So here we have two equations. I'm going to call this equation number 1, equation number 2. We're going to divide equation number 2 with the equation number 1. I want to keep the power of r positive, so I'm going to be keeping the higher exponent of r on the numerator. That's why I'm not doing 1 divided by 2, so that I don't have to deal with negative exponents. Okay, so a1 r to the ninth power divided by a1 r to the third power. Both left and right hand sides would be divided. 125 divided by 64 will be divided by 125. So we're left with r to the sixth power equals 125 over 64 times 1 over 125. R to the sixth power is 1 over 64. R comes out to be 1/2. And we wanted to find the 14th term here. So to find the 14th term, we can go ahead and find a14 would be a1 r to the 13th power. And 14th term will be the first term. We have not found the first term, but we can plug this r either into first equation or second equation to find a1. So 125 equals a1 r to the, let's see, 125 is equal to a1 r to the third power, which is 1/2 to the third power. 125 is equal to a1 times 1 over 8. So a1 would be 125 times 8, which is our first term. That's 1,000. So a1 is 1,000. The first term of this series is going to be 1,000. So let's go ahead and find a14. That would be 1,000 times r to the power 13, which is going to be r to the power 13. That would be 1/2 to the power 13. So we can simplify using the calculator. 1,000 times 1/2 raised to the power 13. And that turns out to be 125 over, when we simplify using calculator, turns out to be 125 divided by 1024. So that's going to be our 14th term of this sequence. The sum of first n terms of a sequence is denoted by summation notation. So summation ai, I equals 1 to n, is a1 plus a2 plus a3 plus a4. So this is a series. This is a series where we are adding all the terms and we're talking about the sum. And all the way up to nth term, that can be written in a compact form using summation notation called sigma as well. So index of summation is where i's begin, and upper limit of the summation will be where i's are going to end. Index is I, lower limit is starting at 1 all the way to n. So if I have summation 4 to the power n equals 1 to 5, that means I would be adding 4 to the first power plus 4 to the second power all the way to 4 to the fifth power. And that's going to be 1364. Sum of a finite geometric sequence. So if we have a finite geometric, this should be actually series, not a sequence. Sum of a finite geometric series. So if I have a geometric series and I want to find the sum of it, we can go ahead and use this formula to find sum of a finite geometric series. For example, 5 plus 10 plus 20 plus 40 plus 80, this is a geometric series because each time I'm multiplying by 2, and I want to find sum of first 8 terms. We're looking for sum of first 8 terms, and we can say S8 would be equal to A1, 1 minus r to the power n, divided by 1 minus r. In this case, we can clearly see A1 is 5, r is the common ratio, which we are multiplying by 2 as we go, r to the 8th power divided by 1 minus 2. Using the calculator, we can figure this out. This is going to be 1275. So sum of the first 8 terms for this series is 1275, and we can find sum of first 100 terms as well without actually writing the 100 terms. So to find the sum of first 100 terms, if that was the question, it would still be 5 times 1 minus 2 raised to the power 100 over 1 minus 2. And using the calculator, we can figure this out. Find the sum of this geometric series. So let's go ahead and write the first few terms, although it's not necessary, but it might help us see our series. 4 times, we're going to start by plugging n as 1, and we're going all the way to 12. So we want to find a sum of all the terms from first term to the 12th term. 4 times 0.3 to the first power, plus 4 times 0.3 to the second power, 4 times 0.3 to the third power, all the way to 4 times 0.3 to the 12th power. We want to see what's the sum of all 12 terms. So in this case, we want to find S12, A1, 1 minus r to the power n. The nth sum formula for first n terms, partial sum formula for n terms is A1, 1 minus r to the power n over 1 minus r. So now we are looking for sum of first 12 terms. So n is 12 in this case. A1 is the first term, which is 4 times 0.3. And the common ratio, if we see over here, my r is actually 0.3. Each time I'm multiplying with a 0.3, r is 0.3. So 1 minus 0.3 to the power 12 over 1 minus 0.3. And using a calculator, we can figure out the sum of first 12 terms here. It's going to be 1.714. That's the sum of first 12 terms for this geometric series. Sum of the terms of an infinite geometric series. We can also find the sum of infinite geometric series. Means the series with infinite terms. The terms never end. That kind of series, if absolute value of r is less than 1, if the common ratio is less than 1, that series converges. The sum is going to be finite and we are able to find the sum. But if absolute value of r is greater than or equal to 1, then we cannot find the sum of that series. That series diverges. So if absolute value of r is less than 1, when you raise it to the nth power, and if absolute value of r is less than 1 and we raise r to the infinite power, that's going to be approximately, that number is almost going to be gone. So that would be approaching to, think about 1/2 to the 100th power. What is that equal to? Let's go ahead and check out 1/2 to the 100th power. That's going to be extremely small number, so that's going to be approaching 0. So we had our sum formula as n equals a1, 1 minus r to the power n over 1 minus r. When r is less than 1, and you're talking about infinite terms, this is almost going to be 0. That term r to the power n is almost going to be 0. So I'm just left with the formula a1 over 1 minus r for infinite terms. So this is the sum of infinite terms for a geometric series. And we can only find the sum as long as the common ratio is less than 1. If common ratio is greater than or equal to 1, the series diverges and we cannot find the sum of such series. So here we want to find the sum of this series. Let's go ahead and first see it's a geometric series. Yes. What's the A1 here? A1 is 3. What's R? What are we multiplying as we go? We can go ahead and divide any two consecutive terms to figure out the R in this case. So that would be R would be 0.1 in here. So now to find the sum of infinite terms, this dot 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 means it's going on forever, it never stops, and we're talking about infinite terms. S in sum of infinite terms is a over 1 minus r, which is going to be 3 over 1 minus 0.1, and that's going to be 3.33. Now, if you want to check, you can go ahead and use a calculator, write the first 20 terms of this series, and see what sum turns out to be. What happens in this case is the terms are becoming so small as we go that adding those terms is not making any difference to the sum of the series. And that's why this series converges. Right, geometric series, what if your paycheck started at $100 a week and doubled every week? How much would be your salary after 4 weeks? So at the end of first week, your salary, you're starting with 100. At the end of 1 week, week 1, it's doubled. After 2 weeks, it's doubled again. 3 weeks, it's doubled. After 4 weeks, your salary would be $1,600. These are the values coming from a geometric sequence. So when you're multiplying with the